All right, hey, how's it going, guys? Happy asynchronous class day Thursday. Now, what you're going to practice today is going to be what you kind of started yesterday, which was multiplying polynomials. Again, we teach that as an area model. Length times width is going to equal the sum of, if we add up each part of the rectangle here. Okay, so we're going to use that thing called generic rectangles here, which allows you to multiply expressions without tiles. First things first, they mentioned this thing called the distributive property. We haven't actually talked about the distributive property so far this year, but talking to some of you guys so far already, you're like, okay, I already know how to do a lot of what we're doing the past few weeks. So you probably already know the distributive property, okay? What the distributive property is technically called the distributive property of multiplication over addition. And that's when you have a term, let's just say that term is A, and you have two other terms on the inside here. We're just giving it one variable for each term here. So here we have something called a binomial, two terms, right? Nomial just means term, B plus C. When we distribute, it's called the distributive property of multiplication. Again, when you see parentheses, it means to multiply, okay? Distributive property of multiplication over addition, okay, over addition. So what that means is if I have this here, I gotta multiply A times by the quantity B plus C. What might that be equivalent to? Well, the thing is, what you get said here, the verb for this is you're going to distribute that A, okay? Distribute that A so it multiplies to B, and distribute that A so it multiplies to C here, okay? Each term on the outside, or the one term that's on the outside, you only have one term outside of parentheses. Look, so only one term outside of parentheses. Those are all one term because you have a coefficient and a variable there. Coefficient variable, x squared, that's a term, it's an x squared piece. The one term gets distributed to each of the individual terms there. So what this simplifies to is A times by B plus A times by C. Let's do an example, right? Let's do an example using actually numbers here. So we have here, what if A is 6, I'm just making up these numbers, B is 5, and C is 2, okay? That would obviously equal 5 plus 2 is 7, times by 6 is 42. But here's another way you can do it. You can use the distributive property. 6 times by 5, that's 30. And 6 times by 2, that's 12. And once again, we wind up with 42. Okay? Distributive property of multiplication over addition. Problems like these, you can just distribute. Okay? So what I'm going to do is distribute here. I'm not going to use a generic rectangle necessarily for these. But here's my 6 on the outside. I'm going to multiply that 6 to each of the terms on the inside here. What's 6 times... So I can break it up here. I can show it like this. 6 times by negative 3x plus 6 times by 2, right? That's what it means. Let's bring the 6 on top of this here. Well, 6 times negative 3x, well, we have negative 3x's. We got to do that 6 times, so we would have negative 18x's total, right? That's what would simplify here, okay? Rule is coefficient, like numbers multiply to numbers, right? 6 multiplies to negative 3, and then x, there's no other x to multiply to, so we just leave it as x. That's it. 6 times by positive 2, well, this is just here, 6 times positive 2, that's 12. So we're adding 12 to that. This is the simplified way I can write out that expression. That's the distributive property, okay? Next one here, we're distributing x squared inside the parentheses. So I know it's distributive property of multiplication over addition, but technically, here we have a subtraction sign. What a subtraction sign just means is actually add a negative number, right? Add a negative number. So you are allowed to distribute over addition and subtraction, right? Because subtraction is just adding a negative, right? Negative here. So here we have x squared times by 4x. That's a little bit tough, right? 4x, and we have x squared multiplying to it, right? That's what that term is going to become here. X squared times by 4x. Well, this is just 1x squared. Remember, numbers multiply to numbers. 1 times 4 is 4, and variables multiply to variables here. X squared times by x. Well, that would just be x times by 4 times by x, right? I count 1, 2, 3 x's, okay? Remember your properties of multiplying exponents, that if you have a common base, the rule is you add the exponents together. So this is 4x cubed, and then here we have x squared minus 2y here. We get minus 2x squared y. That's what I get for that one, okay? Because, again, variables multiply to variables and numbers multiply numbers. Here, negative 2 is just going to the 1, so we're leaving that as negative 2. X squared can't combine with y, right? So we just say x squared is times y, and that's as simplified as we can write that sum right here. Okay, I mentioned sum here because, guys, you could actually do a generic rectangle with this. You actually can do a generic rectangle if you want. You can do the little arrows here, okay? But you can also do generic rectangle for all these problems here. I might do these next two as generic rectangle problems, okay? So What you saw in yesterday's class was that you can make a rectangle out of factors, okay? So this is technically 5t times by 10 minus 3t. This one here is negative 4w times by 8 minus 6k squared plus y, okay? So the pattern that you kind of maybe noticed yesterday is that the first thing in parentheses, the first factor of this product right here, the first parentheses, that's going to be your height, okay? So height of a rectangle is 5t. There's only one term here, so I'm not going to do the generic rectangle the way you've seen it before, because the way we saw it yesterday was maybe for a problem like this, right? Which this one here, this one is 2x plus 3, right? Remember, the height is the first factor, and then the width is the second factor, times by 4x plus 5, okay? That's what this one is down here. Here, this is something called a binomial, 2 terms times by 2 terms. That's why we have 2 for height and 2 for width, right? Two little boxes there. Here, I just have one thing for height. So I'm gonna do 5t, but I have 2 for width. I have 10 minus 3t, okay? It's just another way to do it if you don't wanna do the little distribute arrow here. So here we can do 5t times by 10, that's 50t. 5t times by negative 3t, well, 5 times negative 3, negative 15. T times t, t squared, okay? So what we get as our answer simplified here, it's just a different way to show it. You get 50t minus 15t squared, okay? So that wouldn't actually be in the preferred order of a sum for a polynomial, because you want your lead term, your first term here, to have the highest exponent. So technically I should have written negative 15t squared plus 50t. If you watched my video last time, you kind of maybe got that here. Okay, look at this one. We could just distribute everything, do everything in our heads, but if you're more of a visual person, you can remind yourself that this is our height here is negative 4w of our generic rectangle, right? If we had w pieces, right, we do this here. And then here we got to multiply to each of the terms. We get 8 minus 6k squared plus y, and now we got to multiply. Here's our height. Okay, so what's our area of this one? It's 8 times by negative 4w. That's negative 32w. Again, negative 4 times 8 is negative 32. W times by w to the 0th power, it's still going to be just w, right? W to the first times w to the 0th, just w, okay? So this is going to be, this first term that we're going to have here after we multiply is going to be negative 32w. Here, this would be, we want to write this first. I wrote this kind of a weird order. But anyways, negative 4w times negative 6, well, negative 4 times negative 6 is 24. W times by k squared, we're just going to leave that as w k squared. So here we have plus 24w squared. And then finally, the last one is this, negative 4y. Well, that's just plus 1y. So we're going to leave the negative 4 here. Negative 4 times 1 is negative 4. W times y is just wy. And so we'll do plus wy. Okay, so this is writing it as a sum. Sorry, it's a little messy there, but I wanted to get it done in the example. Okay, so maybe this is a little bit hard for you guys here because these are not super straightforward distributive property problems. This should be a little bit easier. This is what kind of we've been doing in class the last several days here. So write the areas of product and a sum for the rectangle shown at right. So I got a bunch of x squareds here. So that means I got an x squared here, got an x squared here, x squared here. So hopefully you feel pretty confident solving something like this. Okay, so if I had to do this as a sum, okay, sum, let's add them all up. So I have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 x squared pieces. And here we have 1, 2, 3, 4, 5, 6. Okay, so this is a 3 by 3. And actually might write the 3 here on the outside. 3 by 1, 2, 3, 4, 4 y's. Okay, we have 4 y's and widths right here. Okay, so 3 times by 4, I got 12 y's up here. Okay, how many y's do I have down here? I got 12 y's. And here I have 1, 2, 3, 4, 5. And here I have 2y in height. So that means this must be 10 y's here. Okay, 10 y's plus 12 y's is 22 y's, right? 22 y's there, okay? So, oh wait, no, x's. Sorry, this is x here. My bad. That's x, okay? I gave it to you, that's x squared. So what's the side of that? This is length of x. This is length of x if that's x squared, because x times x equals x squared. Anyways, there's plus 22y. And then finally we have our ones. Here we got 1, 2, 3, 4, 5. Okay, 5 for ones. And here we have 3 for 1. So that means there are 15 in here. 5 times 3 is 15. You can count them up. You can verify it if you want here. All right, there's my sum. Okay, so this is pretty easy here. Now I got to get as my product. Okay, so I got to get I might change colors just because I already labeled a lot of this, but let's see if we can piece the rest of this together. So this is obviously 3 here, so we're going to have a plus 3 here. This part of this height, this is x, and that's x, right? Because we need 2 of those to fit in those 2x squared pieces. So this is going to be 2x right here. So as a product, this is going to be 2x plus 3 times by, we got a 5 here, so we're going to have plus 5 at the end of this here. And then here we have 1x, 2x, 3x, 4x's, 4x plus 5, okay? And there we have it. This is the polynomial written as a product, right? Written as a couple factors, height times by width, right? That's going to be equivalent to this, right? Equivalent to this here. Yeah, so just these funky polynomials, like scary looking algebra things, we can see them get scared 2 ways. Once as a sum or once as a product. And they mean the same thing, okay? And we'll see, we'll verify. We'll go in between the 2 formats and prove, actually, that they're the same thing, too, even though we see it here. All right, check this one out. Now examining the following diagram. How is it similar to the set of tiles in problem 365? So they're doing a little bit differently. They put the x squared down here. That's fine. You can do that. Yeah, so let's check it out here. Now examine the following diagram. How is it similar to the set of tiles in problem 365? How is it different? Talk with your teammates. Write down all of your observations. Why did I write it like this here? Well, yeah, 2x plus 3, 4x plus 5. Oh, we got the same thing here, okay? They are the same. So write in a complete sentence. They are the same. Okay, and you guys had a lot of really good observations in class today when you wrote your little slides for this here. Difference between generic rectangle and the tiles is that generic rectangle is just more simple. Okay, right? So it's just one term outside each box. Okay, so it's going to be sort of dictated by the amount of terms you have, how you set up your boxes here. Here, it's like 4x's here, right? You know, a lot of people were saying this one had your combined like terms down here. This one here, you had to set up 1 tile, then 2 tiles, then 3 tiles, then 4x squared tiles, right? So with the 4x here, you can just label it here. Combine like, well, I've got 4x's here. I'll just write it 4x down here. Okay, 1 term outside of each box. So every term is how tall it is, right? This is how tall. Okay, and this is how wide. So what a generic rectangle is just a simplified way kind of doing it here. So write down just a couple observations and you should be good to go. Okay, diagrams like the ones in problem 366 are referred to as generic rectangles. Generic rectangles allow you to use an area model to multiply expressions without algebra tiles. Hooray! Because we want to be able to do our fancy algebra stuff. We want to multiply one math expression to another math expression. What are the rules we need to follow? How do we get it to work out here? Okay, it says draw each of the following generic rectangles on your paper, then find the area of the area of each part, and write the area of the whole rectangle as a product and as a sum. Okay, I got to be doing all this, please. Please follow the whole directions here. So I know it's already drawn out for you here, but please sketch it out. Come on, get used to it here. Outside is 3. This is y. This is plus 5. What's the inside? 3y. 3 times 5 is 15. So there we've proven this, that as a product, which is 3, that term. That's why we only went up once. We only had 1 term in this first parentheses here, first part of the product. The second part of the product has 2 terms, y plus 5. Okay, and then that product is equal to the sum we just found, which is 3y plus 15. We can verify that using the distributive property. 3 times y, 3y. 3 times 15, 15. We're good to go. Okay, next one here, right? You're drawing it out. And you're like, Mr. Ford, why aren't you just doing it on here? Oh, I got 2x, okay? So we didn't need 2 different columns for this because there's no reason to break up an x here and x there. 2x is just a combined term, which is nice. X times x is x squared. 2 times by 1, well, 2 times 1 is 2. Okay, so remember the rule is numbers multiply to numbers. Variables multiply to variables. And you got to use your laws of exponents, right? This is x to the first power times x to the first power, right? If you don't see an exponent there, it means x to the first power. Add the exponents, boom, x squared. Okay, next one up here. Again, sketch it out. Draw the outside. So actually, wait, I didn't run my final answer here. This is x times by 2x. And what does that equal? 2x squared. So that's why that's written out as a product. That's written out as a sum, right? We're not adding anything, but there's no parentheses, right? That's another thing too. No parentheses when you're writing it out as a sum. Another way to tell the difference. Okay, this one here, let's do it here. This is just x plus 5 times by 2x minus 3. And here we have 2x times by x. We've done that a bunch of times. 2 times by 1 is just 2. X times by x is x squared. Here we go. X plus x is 2x, right? No, but x times x is x squared. X times by, well, this is 5 times x to the 0th, technically. Remember, x to the 0th, anything to the 0th power just means 1. So 5 times 1 would be 5. Think about it that way. So x times by x to the 0th, well, it's just 1. It should become x up here. And then remember, 5 times 2, 10. Okay? I have x squared pieces here. I'm going to have x pieces here, and I'm going to have x pieces down here. I just know that because in order for these to be x squareds here, my height needs to be a length of x of some sort. Width has to be a length of x of some sort. So we get x times x gives me x squared. So over here, right, there's going to be just 1x here and 1x here. We just need to figure out how many of them there are, right? There's like the letter x, the variable x, and a certain amount are going to be here. So anyways, 1 times -3, -3x. Okay? -3 times by 5, -15. Okay? And there I'm going to get my sum, which is going to be 2x squared plus 7x minus 15. And there is my product. There is my sum. And yeah, why don't we keep jamming away? See how far we can get with this one here. 6y times by 4y squared. That's 24y squared, my friends. And then we got 6y times by -7. That's -42y. -1 times 4y, -4y. -1 times -7 is +7, right? A negative times a negative is a positive, right? Is a positive. So you're flexing those like skills your teachers have been telling you over the last few years, right? Negative times a negative. Negative times a negative is positive, right? All the rules kind of add up that we have here, okay? What's my height? My height is 4y minus 7. And remember, area is the product of height times by width, or height times by base times by height. My base here is 6y minus 1, and that is equivalent, right? You're just getting tons of practice today, which to 24y squared. Here, let's combine our like terms. We get -46y plus 7. We are good to go. We get those two down here, okay? How did the area of the individual parts of each, how did you find the area of each individual parts of each generic rectangle, okay? One, multiplied all of the outside terms, okay? Right, bottom to side, right? Bottom to side, each term, right? This bottom one to that side one, this bottom one to that side one. So we did all the terms on the bottom times all the terms on the top, every combination we could do. And then finally, after we multiplied, we added, okay? We added, right? Combine like terms. We combined like terms and added here each smaller box's area to determine the area. Well, that's the individual parts here. Actually, explains the whole thing here. Okay, wrapping up here. I got a crying baby in the back here. I'm gonna let you do the generic rectangle challenge, right? I think you guys can figure that out. This one here is gonna have multiple answers, right? This will have multiple answers here, so don't get too scared away from this. Sometimes you'll have multiple answers. Sometimes it kind of happens. Not all the time though. Multiple answers is just they didn't give you enough information in this problem to get a specific answer. There are multiple ways to do it. Okay, check this one out here. 368. Multiply and simplify the following expressions using either a generic rectangle or the distributive property. So here we're definitely going to use the generic rectangle. Don't use the distributive property here because it gets really messy, right? You gotta multiply 4 times here, okay? 4 times. This is super messy. Guys, generic rectangle is how I want you doing this here. X plus 5 times by 3x plus 2, okay? Gives me 3x squared. 3x times by 5 is 15x. 2 times x is 2x. 2 times 5 is 10. And I can combine like terms. 3x squared plus 17x plus 10. And good to go there. Generic rectangle. That's what it's all about. Right? All about, my friends. We got this. Get the powers in your hands. Let's do this. Let's learn the math here. 2y minus 5 times by 5y plus 7. Okay, gives me going to be 14y squared here. 7 times by 2y. And just let it flow. 14y. 7 times -5. -35. 5y times -5. Is going to be -25y. Okay, combine like terms. Let's go ahead and write the answer up here. 14y squared minus 11y minus 35. Oh, messy. Okay, but we got that as a sum now. Okay, here you might want to do the distributive property, but hey, I would just notice here, this is something called a monomial. What does mono mean? Mono is like a disease, right? But mono means one in Latin. So this is called a monomial. Okay, it means one term. That means our height is just going to be the height of that one term. 2x pieces stacked up here. Generic rectangle would look like this, right? Just the height of one term, a width of two different terms. We have a width of 6x squared. I know it's weird to have a width being like a quadratic like this, like a squaring thing here, but it still works, right? You can still use this little trick here. Generic rectangle, get your answer. 3 times by 6 is 18. X squared times by x is x cubed. And here we have negative 11y times by 3x. Negative 11 times 3 is negative 33. X times y is just, well, x times y. And there's your answer. 18x squared minus 33xy. And finally, last one here, and then I'll cut the video off. You know, this assignment looks long, right? Looks long. Is it long? Ah, it's not too bad. Come on. If you just did it along with me. Oh, this one's a little bit tricky. Here, check this one out. They said this is a monomial times by something called a binomial. You don't have to worry about these words too much this year. Usually I have people memorize them and know what they are here. But one term times by two different terms, right? Means we're going to multiply twice. This is a little different here. Here we have a binomial. Okay, bi means two, right? Bicycle. How many pedals do you have on a bicycle? Not pedal. Well, you do have two pedals, but how many wheels do you have on a bicycle? 2 wheels. Okay, so this is called a binomial because there are two terms. And then how many on a tricycle? How many wheels do you have on a tricycle? Well, you have 3 wheels on a tricycle. So you guessed it. This is called a trinomial. So that means our height is going to be 5w minus 2p. Our width is going to be 3w plus p minus 4. That's right. We have 3 terms to lay out there. So we're going to have to multiply these 2 terms to all 3 of these terms here for a total times we multiply by being 6 times. Wow. Wow. Okay. So numbers multiply. 5 times 3 is 15. W times W is W squared. Negative 2 times 3, negative 6. P times W is just PW. P times W, again, is just PW. So I have to combine these like terms. Sometimes I circle them if I'm going to combine. So there's a PW here. There's our 5. Don't forget about that. 5W times P is 5PW. Okay, then we have P here. So we're going to get a P squared action up here. P times P is P squared. Negative 2 times 1 is negative 2. Negative 4 times negative 2 is 8. And then we got the P. And then finally, we have negative 4 times 5 is negative 20. And that's W here. Okay, check for like terms. Okay, these are the only like terms we need to combine. We got a P squared here, got a P there, got a W there, got a W squared there. So those are all different. So my answer, and I probably got one of these wrong. I like when people challenge me on it and tell me about that if I got them wrong. It's going to be 15W squared. I'm going to take away 1 PW, okay, because that's what these equal. Right, that's what that combines to. 5 PW, take away 6 from there, you're negative at that point. Negative PW. And then let's do negative 2P squared. So maybe I'll cross them off as we're going through. So talked about those 3, just these 2 left. So then maybe minus 20W and then plus 8P. All right. So that's what I'm going with here. All right, generic rectangle challenge. How do you get the outsides when you have the insides? Ooh. Okay, these are all written out as sums. Okay, we have the sum. This is going to be a question. This will be a skill that we'll have to do later on in the semester, right? When you start with them as a sum, xy plus 3y, how do you write it as a product? Interesting. How do we write it as a product? Well, we have the inside. We just got to get the length times width. That's it. Or base times height, right? What do you have here? So if this is xy, this has got to be y here, right? Because x times y is sort of working backwards. Well, if this times this gives me xy, and I know one of the factors is x, then it needs to multiply to y. Okay? Well, my y over here, what's going to get me to 3y? Well, 3 times y. Okay? So what's my answer here? Y times by x plus 3. There we go. We have it factored. That was the first thing we factored all year, right? This is called the sum. Rewriting it as a product, right? It means writing it as factors. This thing here has 2 factors. It has y as a factor and x plus 3 as a factor, because factor means things that multiply to become a certain expression. So y times x plus 3, that gets you there, okay? Check this one out here. So this is x squared up top. This has to be x. That has to be x. Here's my 12x, so x plus 12. And then we're going to get this. This is a 5 over here, so x plus 5 over here. And this will be 5x. 12 times 5, 60. And we're good to go, okay? So we're going to get x plus 12 12 times by x plus 5 equals x squared plus 17x plus 60. Okay, so this is just sort of a little puzzle for you guys right here. So you didn't get the whole sum. You had to deduce what the whole sum was based on what you saw here and here, and what had to be on the outside, and what this here means that 5x would have to be there. So anyways, I'll leave the rest for you, or it's really just one problem here. And then this one, there's multiple ways to do it. Good luck. Send me an email if you have any questions. That's my geometry homework. So if you have any questions, and hopefully try to go through this quickly so you're not stuck here watching this, but rewatch things maybe that were a little bit confusing the first time. But email me if you have any questions. Go ahead and message me. Okay? Take care, guys. Have a good day. Bye.